Students, today we are talking about a problem we all are facing. Actually, when we were doing our A-levels, lots of students actually they have this problem. It's actually problem with math. Maybe, yeah, students who are actually doing maths, they won't have a problem with it, mathematics. But other students or even some mathematics students also, they might have faced this problem. In physics, when we are doing physics questions, we have to get the ratio values. So doing ratio questions, some students actually find it really difficult. Maybe students who are really good with math, they don't have a problem with that, so that's okay. So this actually video is for the students who find it difficult to work with, yes, ratio type questions, because in some questions actually we can easily get the question done by using ratio method. Let's say even in mechanics we can apply ratio method. In many cases electricity we apply ratio method. Even in heat lessons also we can apply ratio method. So I'm going to give you a couple of examples and let's go through by each scenario and let's try to learn something from it. Stick with me. I'm giving you an easy example here, right? In the ratio method, just think of the questions you were doing back in grade 6, 7, 8, maybe grade 8, 9, 9, 10. No, you may have studied ratios, how to divide certain things into ratios. So in this example, actually, I'm giving you that we have 300 orange, right? These orange we have to divide into two categories, as in two sets. Two sets. Set A should get 1 and set 2 should get B. 1:2 ratio. So through this ratio, we have to divide this 300 orange. Easy question. Yes. So basically what you do, just think of what you are doing now. So we get a fractional value. What is the fraction out of this 300? We get for A and we get for B, right? So how do you find the fraction? Basically what you do, we add these two. That becomes 3. That's the denominator. Then upper part we put 1 here and 2 goes there. And 3. This is the fraction. Now we have the fraction. So what we do, we multiply that value 1/3 into 300 and 2/3 into 300. Simplification, we get 100 over here and we get 200 here. So once we add these two, yes, you can easily see 100 and 200, that becomes 300. Easy question. So basically some of the students actually they don't have this ability. I have noted it. So I'm telling these students actually go through with your O-level notes and all that, find similar type of questions, practice, because practicing ratio method, how to divide certain things into ratios, that's a really good skill. It's a must skill, actually must have skill for our A-levels. Right, let's move into the other now. Right, students, just to be a little bit clear again with this 300 orange question, let's say now we have 3 categories. Say now we need 3 sets, A, B and C. So the ratio will be, let's say 1:2:3 ratio. So what we have to do is we have to apply the very same method we applied earlier. So we need to get the fractional value. Right. So how do you find the fraction? You add these 3 together. 1, 2, 3, 3 and 6. 6 goes down as the denominator and 1/6. 2/6 and 3/6. That's the fraction basically we need. By using these fractions we divide, we distribute actually the orange in between A, B, C. So it's 300 into 300 into and into 300. Here we get 50 and here we get 100 and here we get 150. So A gets 50 and B 100 and C of course 150. So this is the method for getting ratios in 3 ratios. Even if we get 4, 5, 6 ratio values, we have to apply the very same. Right, moving into the other scenario. Right, students, now the third one actually. Here say now again we have the same orange, right? 300 orange. Now we have the ratio half is to write it in this 3 is to say now this ratio, right? half is to 1 or 3 ratio. This is the ratio we were given. Actually, in this method, actually we are not going to make it to the fractional value directly because we do not have the value, right? Remember the method we did earlier? So we need to add these two, right? And then we create the, we form the denominator. So here actually we cannot do it. So we may have the ability to do it, but we don't do in this way. So what we basically do is we make it a proper value. So it's a fractional value here we have. So what we do is we multiply these two by using the common denominator of 2 and 3. Right. So let's multiply. The common denominator will be 2 into 3, 6. That's the common denominator, LCM. 6 LCM value, right? So multiply 6, this becomes 3. Multiplied by 6, multiplied by 6, this becomes 3. And 3 is to 2 ratio. This is the ratio. Through this ratio, again we divide 300. So 300, same method. Now we can easily add these two. So that this basically becomes 5 into 3 and 300 into 2 over 5. So here we get 60, 180 and 120. Once we add these two, that becomes 300. Easy method. So basically this kind of ratios we need to apply actually in capacitor questions. Actually when we allocate capacitors, when we allocate voltage across capacitors, actually we need this ratio because Q equals CV and V divided by Q over C. So V proportional to 1 over C. So if you need to apply, if you need to allocate potentials according to the capacitance, so then you need to apply 1 over C ratio. So in this method. So some of the students actually find it difficult even in these methods. That's why I'm telling you, practice these type of questions, these type of ratio methods. You have to have, it's a must skill, right? Remember that you have to have that skill, right? So I'm going to walk you through a couple of questions, a few questions, not that much. So just try these questions so you will understand the question types actually. So practice as much as possible. Let's try it now. Students, this question is from rotational motion. Actually this question you can see if you go through a past paper book, actually there are so many questions from this type of questions. So it's always better to work with these type of questions. There are many ways that you can get the answer, but let's try to get the answer from ratio method, right? Let's try it now. Alright students, moving into our very first question. A disk of radius r and mass m rolls down an inclined plane. When the disk hits the bottom of the plane, find the fraction of rotational kinetic energy from the total kinetic energy, right? So actually, what we can easily do is we can apply conservation of energy for rotational kinetic energy and linear kinetic energy. Let's apply the equation. So here total energy will be mgh when it comes to the ground. So mgh will get converted into kinetic energy. Linear kinetic energy half mv squared and rotational kinetic energy half I omega square, right? So what we are trying to do is we are trying to incorporate the ratio method here, not so. Let's try to write these two in same letters, right? Same form. So it's basically half mv squared first one. So I can write like this: I equals half mr squared for disk, right? And then omega I can replace actually V over R because R omega. So I'm going to apply it there. So here I can write half into, again I mean half mr squared and omega V squared over R squared. Let's simplify it now. Half mv squared plus, now you can see 2 becomes 4 and this r squared cancel off. So I'm getting mv squared by 4. So to this ratio mgh we should divide mgh in between half mv squared and mv squared by 4. So I'm going to take the ratio of these two. That's easy, right? Let's take the ratio here then. So the ratio I have to take is half and 4 because here mv squared and mv squared is common. So this is the ratio I have to take. To this ratio mgh I have to divide. So just like we did earlier, what we have to do is now we have a fractional value. We need to take a fraction. Right. So I'm going to do, what I'm going to do is I'm going to multiply it by 4, the LCM value. So multiplied by 4 and multiplied by 4, yes, I'm going to get 2 is to 1. So this is the ratio now we have. So this ratio goes to 2 goes to linear kinetic energy and 1 goes to rotational kinetic energy. So what we need is, yes, rotational kinetic energy. So the fractional value I am getting 2 over 3 and 1 over 3. So 1 over 3 of the total energy, one third of the total energy is rotational kinetic energy. Basically we have the answer, right? Rotational kinetic energy 1 over 3 is our answer. So I hope you understood the method. So just practice these methods. It will come really helpful if you can really practice these methods. Right, let's take a question like this now. So in this, actually this is a capacitor question. Right, they are asking us to find the potential difference across this 2 microfarad capacitor. This 2 microfarad capacitor. So let's apply the ratio method to find the potential difference across 2 microfarad capacitor. So these 3 capacitors actually, these 3 are parallel. So let's take it as parallel now. So parallel capacitors, I hope you know how to add them. So we need to add parallel capacitor. We can directly add the parallel capacitor 3, 6, 3. So it's basically it's 12, right? So it's like we have 12 microfarad capacitor here, and then we have 2 microfarad capacitor. In between we have 70 volt, right? Again we have to apply the ratio method now. So then the Q equals CV, of course you know that V proportional to Q over C, V proportional to 1 over C. So what we have to do is we have to take the reciprocal value of the capacitor. So 1 over 12 is to 1 over 2. Just like the method we discussed earlier, what we have to do is we have to multiply this value by the LCM value. So LCM value will be 12. So multiplied by 12 we get 1 is to 6. That's the ratio actually. So then let's get the fraction from it. So once we add these two, that becomes 7. So 1 over 7 and 1 over 6, that is the fraction. So 1 over 7, 6 over 7 is the fraction for 2 microfarad. So 6 over 7 into the given potential 70, so 60 volt, that is our answer. Easy method. Alright, moving into a current electricity question. Let's read the question now. If the circuit shown below, the internal resistance of the battery is 1.5 and Vp and Vq are the potentials at point P and Q, what is the potential difference between P and Q? Right. To find this actually I'm going to apply the the ratio method. Right. So but again actually before applying ratio method I need the potential difference across 3 and 2 here, because 20 volt actually will give potential to this part and this 1.5 ohms as well. So what I have to do is I have to allocate the potentials for 1.5 ohms. So what I'm going to do is I'm going to get the equivalent of these, right? 3 2 5 2 3 5, so that's 2.5. So then the circuit would be something like this, 2.5 here and we have 1.5 here and we have 20 volt, right? So let's apply the ratio method. 20 volt because 1.5 and 2.5 are in series now, so the ratio should be 1.5 and 2.5. How do you know it's this ratio? Because V equals IR and we know V proportional to R. So resistance ratio equal to the potential ratio. So 1.5 is to 2.5. 1.5 is to 2.5. So I'm going to divide it by 0.5. That's 3 and 5. It's easier to get the ratio now. So I'm going to take the fractional value 3 over 8 and 5 over 8. I only need the potential across 2.5, then 5 over 8. That I have to multiply it by 20. Right. So 20 into 5, that's 100 divided by 8. Yes, 100 divided by 12.5 volt. So we have potential of 12.5 across here. Right. 12.5. Now we have the potential difference 12.5 here. So what I'm going to do is I'm going to ground it here. So the potential here will be 0 and potential here will be 12.5. So here we have the higher potential, lower potential here. So I'm going to apply again the ratio method. 3 in this path, so it's 3:2 ratio. The fraction value 3 plus 2 5. So it's 3 over 5 and 2 over 5. Since it's 0 here, if I can find the potential difference across 2 ohms, then I can find the potential at P. So 2 over 5 into 12.5. 1, it's 2.5. 2.5 into 2, it's 5 volt. So potential here Vp, that becomes 5 volt. Right. Again VQ, the potential difference, same method, 2:3 ratio. Now again 2 over 5 and 3 over 5. Now we need 3 over 5. That again multiplied by 12.5. I'm getting 2.5. So that becomes 7.5 volt. So potential here becomes 7.5 and here 5 volt. So VQ is greater. Yes. And the potential difference 7.5 minus 5, it's 2.5. So if you can apply properly the ratio method, it's easy to do the question, one of the easiest methods. So practice as much as possible. You will be really familiar with these type of methods. Students, as we all know, practice makes it permanent. So just keep practicing in the correct way, right? Because practice makes it permanent. So if you practice it wrong way, and it'll be permanent, right? So keep practicing in the good way and try lots of questions, make it a skill. Feel good to go.